Hey there everyone, welcome back to another video. Today we'll be reviewing number concepts. That's the first chapter of IGCSE Mathematics. Let's get started. So the first thing we must know are the different types of numbers. We have natural numbers, which are any whole numbers from 1 to infinity, and they are also sometimes called as counting numbers, and 0 is not included. So 1, 2, 3, 4, 5, 6, 7, 8, all the way to infinity are all natural numbers. Odd numbers are numbers that cannot be divided exactly by 2, such as 1, 3, 5, 7, 9, 11, 13, 15, 17, etc. Then we have even numbers. These are whole numbers that can be divided exactly by 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and all the way to infinity. Integers are any of the negative and positive whole numbers, including 0. Basically, every single whole number, so which includes all the negative numbers to infinity and all the positive numbers to infinity, including 0. Then we have prime numbers, a whole number greater than 1 which has only two factors, the number itself and 1, such as 2, 3, 5, 7, 11, etc. Square numbers are the product obtained when an integer is multiplied by itself, such as 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So this 1, 4, 9, and 16 are all square numbers. Then we have fraction, a number representing parts of a whole number and can be written as a common or a vulgar fraction in the form of a over b or as a decimal using the decimal point. So we have 1 over 2, 1 over 4, 1 over 3, 1 over 8, 13 over 3, 2, 1 over 2. This is called a mixed fraction. Mixed fraction. Like the one we have over here, 2, 1 over 2. And then we have something called improper fraction. This is an improper fraction. If you want to change a mixed fraction to an improper fraction, this is what we do. The denominator times this number plus this number all over this. So let's say we have a, b over c. In order to change it to an improper fraction, we do this. C times a plus b all over c. That's how it is. And you do this first. You don't cancel the c's, okay? And yeah, then we have 1.2, multiples and fractions. Basically, a multiple is a number that which is found when you multiply the number by a positive integer. The first multiple of any number is the number itself, the number multiplied by 1. Example, what are the first three multiples of 12? Whenever you're supposed to find the multiples, let's say that this is the first three multiples. So 12 times 1, this is the first, 12 times 2, this is the second, 12 times 3, this is the third, this is basically 12, 24, 36, and this goes on forever. So basically, as I said, when any number is multiplied by the number itself. Then is 300 a multiple of 12? How do we find that whether 300 is a multiple of 12? 300 divided by 12. If it gives 0 in the remainder, then yes. Okay, let's look at this. 12 times 2, 24. You get 6, 0, 60, 12, 5, 60, 0, 0. Once we have gotten 0, 0, and we have our number here, we can say, yes, 300 is a multiple of 12. Now, we must also look at the lowest common multiple, often known as LCM, is a multiple of two or more numbers in the smallest number that is a multiple of all the given numbers. Basically, let's look at an example. What is the LCM of 3, 4, and 18? Whenever you're told to find LCM of numbers like this, what you do is you prime factorize them. 3, when you prime factorize it, is 3. 4 is 2 squared. And 18 would be, 18 is basically what? 9 times 2. So that's 3 squared times 2. Now what I want you to do is identify how many different types of numbers there are. So we have 3, this is the first, 2, 3, 2. So we can see that there are only 2 different numbers, 3 and 2. So what I want you to do is make sure 3 has a 2, 3 also has 2 as a multiple of it. So we can say times 2 power 0. And then the same for 4, which is 3 power 0. And any number to the power 0 gives 1. So 2 power 2, 4 times 3 power 0, which is basically 4. Now what I want you to do to find the LCM is to find the greatest number or the greatest power of each number. 3 has a power of 1 here, 0 here, and 2 here. 2 is the biggest, so I'll write 3 power 2 times 0, 2, 1. 2 is the biggest times 2 power 4. Let me bring it here to the top, LCM. So 3 squared is what? 9. And 2 power, sorry, this is 2. 2 power 2 is 4, which is 36. And hence the LCM of 3, 4, and 18 is 36. That's how you find the LCM of any number. Then we have factors, okay? Factor is a number that divides exactly into another number with no remainder. For example, 2 is a factor of 16 because it goes into 16 exactly 6 times. 1 is a factor of every number. 1 is a factor of every number, and that's something we must remember. The largest factor of any number is the number itself. So these 1 and 2 points that we stated are key and very important that we must always remember. So let's look at an example. Find the factors of 12. So we have 12, 1, 12. Is 2? Yes, 2 is a factor. Is 3 divided by 12? You get a whole number, 4. So 3 and 4 are both prime number factors. 6 is also a factor because it's divisible. When divide 12 by 6, you get 2. Is 7 a factor? No. Is 8 a factor? No. Is 9 a factor? No. Is 10 a factor? No. Is 11 a factor? No. But yes, 12 is a factor because, as we said, the largest factor of any number is the number itself. Then we find pairs of numbers that multiply to get to exactly. So 1, 2, 3. So we have 3 pairs. And 1, 2, 3, 4, 5, 6. These are all factors of 12. When we do the same for 25, we have 1 is a factor. Is 2 a factor? No. Is 3 a factor? No. Is 4 a factor? No. Is 5 a factor? Yes, 5 is a factor because 5 times 5 is 25. 6, 7, 8, 9. None of those are factors. Hence, 25 is its biggest factor as well. So it has 3 factors. And the same for 110. And the answer for 110 is 1, 2, 5, 10, 11, 12, 22, 55, and 110. Now, highest common factor is the of two numbers or more numbers is the highest number that is a factor of all the given numbers. I know this is really confusing, but let me just break it down. Whenever they tell you to find the highest common factor of any numbers, mostly they'll give you two numbers. I've given three here to make it complicated so that you, like when you do an easy question, it will be easier for you. 22, always prime factorize. What do I get? 2 times 11. 2 is a prime number, 11 is a prime number. 33. 3 times 11, prime number, 121. We get 11 times 11, or let's write 11 squared. Now the same old method, times 3 power 0, times 2 power 0, times 3 power 0, times 2 power 0. Now we see they all have three numbers, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now whenever it is highest, you find the lowest powers. And whenever it is lowest common multiple, the lowest or least, you find the highest powers. So to find the HCF, let me write it on the top here. What's the lowest powers of 2? The lowest power of 2 is 0. What about 3? It's 0. The lowest power of 11, 11 is 1. So it's 2, 0 times 3 power 0 times 11. And hence the highest common factor of 22, 33, and 121 is 11. Then we have prime and composite numbers. The prime, this is the one we are talking about. Prime numbers have exactly two factors. One and the number itself. composite numbers have more than two factors. The number 1 has only one factor, so it's not a prime or a composite number. Now, from this table, from 1 to 100, we have all our prime numbers circled, and composite numbers cancelled. So as you can see, all the prime numbers from 1 to 100 are 2, 3. Okay, let me use a darker. Yes. We have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, all the way to 100. And the ones that are cancelled are all composite numbers because they have more than two factors, right? Now it's good that if you're able to memorize all the prime numbers from 1 all the way to 100, that'll be really good. Because most of the times, IG people, they ask you, list all the prime numbers between 20 to 40. I don't have them memorized, but I use a simple trick. The trick is I first write down all the numbers. Let me do that here. From 20, 21, 22, 23, 23, 24, 25, 26, all the way to 40. Then I ask myself, is 20 a prime or a composite number? 20 has more than two multiples, so cancel. What about 21? The same. 22, the same. 23, does 23 have any other prime factors except factors except 23 and 1? No, right? So 23 is a prime number. Then I write 23 over here. What about 24? More than two factors. 25, more than two factors, and all the way to 40. And that's how I get my answers. Let's look at square and cube numbers. A number is squared when it is multiplied by itself. For example, the square of 5 is 25. 5 times 5 is 25. As we said, square is when you multiply a number by itself. The symbol for the squared is 2. So like n2, this is our number. And this 2 shows us that the number is squared, which is basically n times n, right? Blah 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 is 5 power 2. So yes, 25 is the same as 5 times 5 or 5 squared. It's not 52, just so that you know. You don't write it like this. The 2 is a superscript, so on top like this, okay? The square root of a number is the number that was multiplied by itself to get the square number. So 25 is a square number, and to get which number it was multiplied by itself to get 25, this is the sign we do. This is the square root sign, and we know that 5 times 5 gives us 25. That's why our answer is 5. It's called the square root, and yeah. Then we have cube numbers and cube roots. The same applies. Instead, this time is the number 3. Cube 3, square 2 is the same as n times n times n. And this time it's not square root, it's cube root. And how do you draw that? You have your symbol like this. Because it's cube, you write 3 this time, right? So what is it? What's the cube of 2? 2 times 2 times 2, which will give us 8, because 2 times 2 is 4. 4 times 2 is 8. And that's all for square and cube numbers. Now this is the order of operation. We often remember it as BIDMAS or BODMAS, which stand for bracket, order, divide, multiply, add, or subtract. This tells us that whenever we are given an equation, we are first supposed to solve the brackets, then the order. The order means square or square root or square. It's not only for square root or square, it can also be cube, or it can be to the power, fourth power, and all. Then we have divide or multiply. Oops. Whichever comes first, you do that from the left hand side, then add or subtract. And in different books as well, we have PEMDAS. I usually prefer board mass or bit mass, but if you remember pen mass, then no problem. Which also stands for parentheses, exponents, multiply, divide, add, and then subtract. Then rounding numbers. In IGCSE, you're often required to round your answers to 2 decimal place or 3 decimal place. Okay, let's look at this. Let's use blue color. So we have 64.839906. Now, if you're supposed to round this to the nearest whole number, the nearest whole number means that there are no decimal points, okay? So what you do is the decimal points start after this number, right? So you look at this number. Is it 5 or bigger than 5? If it is bigger than 5, then this you add 1 over here, so it becomes 65. But if this 8 were to be a 3 or any number below 5, then this will remain as 45. Alright, and let's look at one decimal place. One decimal place that after a whole number, after a decimal point, only one number should be there. Now, how do I round this? We look at the number next. 3 is below 5, so nothing changes. This remains our answer, becomes 64.8. Then let's look at two decimal places. Okay, so 64 whole number. Oops, let me just delete that. 1 2 decimal place. You look at the number bigger than 5, so you round up. So round up means to add 1, 64.84. Then let's go with this color. We have 3 decimal places. 3 decimal places. So 1 2 3. Draw a line. Is it bigger than 5? Yes, so you add 1. Now what happens to 39 when you add 1? It becomes 40, right? So that's how you write it. 64.840. The 0 needs to come. And that's basically all about rounding numbers. So here we have some practice questions. I'll solve them with you. List all the factors of 68. Okay, we have 68 is divisible by 1. It's divisible by 2. It's divisible by 3. Is it divisible by 4? I don't think so, because 68 is basically 40 plus 18, and 18 is not a factor of 4, so 4 is not a factor. 5 is 5 a factor? I don't think so, because the number doesn't end with 0 or 5. Is 6 a factor? Nope, 6 is not a factor, because 6 times 10 is 60, and 6 times 11 is 66, and this doesn't fit in it. Is 7 a factor? Let's see. 7, what times 7 can give us 68? As long as I know 7 times 9 is 63, and 7 times 10 is 72, 68 cannot be a possibility. What about 8? 68 divided by 8? Nope. What about 9? 9? I don't think so. What about 10? Nope. 11? Nope. 68 divided by 12? Nope. What about 13? Nope. So yeah, this is how you basically go about it. It's not divisible by 14 or 15 or 16 or 17. Okay, wait, it's divisible by 17. It's divisible by 17. Then what times 17 is this thing? 68. Wait, 17 times 4. That means 4 is also this thing, a factor, right? Then 68 divided by 3 would give us, wait, 3 is not a factor. Sorry. I didn't look at this. It's rather 4 here, because 60 is divisible by 3 and then 66. So yes, then what about 68 divided by 2? That gives us 34 and 68. So 68 times 1, 34 times 10. So yes, These are all the factors of 68. Yes, sometimes it can take time. You have to think and go over each number and then divide them and see 34 and 68. Then put one pair of brackets into each equation or each calculation to make it correct. So, now this is where you analyze it. You first try 7 plus 3. If I put a bracket here, what do I get? 10 times 5 minus 1? Nope. Then you leave the 7 and let's try 3 times 5. What's 3 times 5? 15. 15 plus 7, you get uh, 22 minus 1 does not give us 19. Then you try 5 minus 1, which gives us 4. 4 times 3. You use BODMAS here. BODMAS. So brackets first, multiplication next, and then addition. So this gives us 4 times 3, 12, plus 7, which gives us 19. Hence, you put the brackets here. That's how we do it. Now, I want you guys to answer this and put the answer in the comment. Let's see who gets it. Winner gets a shout out, I guess. Yeah. Find the reciprocal of this. I don't think I've taught you guys in the video, but then let's skip the ones we haven't done. I talked about this. Any number to the power 0 is 1. Let's calculate this. We talked about square numbers. So 3 squared, 3 times 3, which is 9, plus 3 power 4. 9 times 3 is 27. 27 times 3 is what? 717, 1, yeah, 21, 6, 81. That is why 81 plus 9 gives us 90, and hence 90 is the answer. I haven't taught you guys this as well. We'll look at this one in the next video. And that was all. I hope you enjoyed and learned something new. Make sure to like, share, and subscribe. Till then, see you in the next video. Ta-da.